Okay, so what I'm going to do is I'm going to go over the problem 7 and 9, I guess, in your book. This is actually the second time I've done this. I just screwed up the recording the first time, so apologies for that. But here we go. So we're going to be looking at problem 7 and problem 9, and this is from the second attempt in your that you had for exam 1. The problems are numbered differently in each attempt. So this is the second attempt. All right. So the concepts that you need in order to do these problems are the concept of limit from the left, limit from the right, limit, and function value. So let me write these down. Limit from the left. So the limit from the left is, written like this. Oh, wow. Why is, okay, I don't know. Limit, let's say x goes to a with a minus sign there, f of x. So from the left has a minus sign. Then you have the limit from the right, which has, of course, the same symbols, but with a plus from the positive side. Then you have what we call the two-sided limit, or just the limit. So, see here, erase. I need to make my eraser smaller. Hold on. Okay. Limit or two-sided limit. Could be called either way. And that's written as limit x approaches a, no symbol, plus or minus on it. I mean, it could have a symbol, it could be negative a, but there's no symbol right here. Okay. And then finally, we have the function value here, which I guess I didn't erase. So, right, function value. Oh, okay, hold on. Back. There we go. And then you have a function value, and the function value you just write f of a. Now you don't actually use this in the problems that we're doing today, question 7 and question 9, but I'll still explain it just because it helps keep things straight. So your problem 7 on the exam looks something like this. So we have this graph, and this isn't perfect, but it's plenty good enough for us to do this. So here are the things that they could ask about this. So first of all, there's something interesting happening at x equals 2. So that's why they are going to be doing limit as x approaches 2. But remember, there's going to be 4 different things they could ask here, right? They only ask one, but the 4 that they could have asked for would be the limit from the left, which would have been the limit as x approaches 2 from the negative side of f of x. They could ask about the limit from the right, which would be the limit as x approaches 2 from the positive side of f of x. They could ask about the limit, which would have been just the limit as x approaches 2 of f of x, or they could ask about the function value, which they would have just said f of 2. So those are the different things that they could have asked. Okay, now limit from the left and limit from the right, let's talk about these first. So I'll try to color code them here. So we'll do limit from the left here. Just divide these up vertically. All right, so we want to do the limit from the left. Now what that means is you have x equals 2 right here. So if you are on the left side of x equals 2, that means you're on this piece of the graph. This is the left of x equals 2. So when we're doing the limit as x approaches 2 from the left, you're in this piece of the graph. So you want to just imagine that you're somewhere on this piece of the graph and you're heading towards x equals 2. Well, x equals 2 is here. So if you're somewhere on the left piece and you head towards x equals 2, then you just follow this curve this way until you get to x equals 2. And you end up right here. This is where you end up. So this is going to be your limit as x approaches 2 from the negative 6, or x approaches 2 from the negative side. So yeah, you end up right here, and the y value there is negative 6. So this answer is negative 6. That's what you get on the left. Now, on the right, we're going to be doing the same thing. But this time, you're on the right side of 2. So instead of being over here, you're over here. This is the right side of 2. So you're on this piece of the graph. So you want to head towards x equals 2 from this side. So if you were just somewhere on the curve and you headed towards x equals 2, you would just trace the curve and you would just end up at this point right here. This has a y value of negative 3. So that's your answer here, negative 3. So you just have simply left side and right side in order to come up with these negative 6 and negative 3 numbers. Now, we haven't talked about the dot here, the solid dot, open circle. And that's because you don't care about the solid dot or the open circle here for these and for this. You only care about where you get to if you follow the curve. So you follow the curve here, you get to negative 6. You follow the curve here, you get to negative 3. Solid dot, open dot, doesn't matter. So that's why these come up the way that they do. So for these, all of these, we are, well, let me just write something here. So you're just going to trace the curve. This way. Could write actual letters here, hold on. And for this, you're going to trace the curve that way. And I guess I'll color code that as well, just because. Right? So left and right. But it's from the left, which is actually left to right. And this is from the right, which is actually right to left. So that's how you get those numbers. And then for this third one here, what you do, sorry, I'm getting a different color. For this one right here, what you do is you have to go from both sides, which basically means if these two numbers are the same, then what you get here is the number, but only if it's the same. So this is going to be does not exist. And the reason it doesn't exist is because the previous two answers are not the same. So this is, two-sided. So it only exists if the left and right hand limits agree. Come up the same here. So obviously these did not come up the same because one is negative 6 and one is negative 3. So this one does not exist, right? So if you trace the curve on the left and from the right and you don't get the same number, then there's no limit, right? So obviously left and right are getting you to different places, so no limit. So that's what you do for the two-sided limit. So then finally we get to the function value, and the function value, that would be where the solid dot is. So this would be if Well, where it is if it exists. So where there is a solid dot at, no, not at x equals 2. And then that's only if it exists. And it does exist because we can see that there's a solid dot right here. So this is going to be the function value. All right. So then what's that function value? That looks like -3. Okay. And so that's how the limits work. So let's look at the other one, problem 9, which is the same exact concept here. Oh, well, actually, what was the answer to the question? So looking at the answer to the question, um, what they actually asked for was the two-sided limit. So on this problem, they asked you for just the limit as x approaches 2 of f of x. And it doesn't exist because the left and right hand limits are not the same. Right? So the answer should have been that, which is the empty set, which is how they say that there's no answer. Okay, so let's look at problem 9 now. So problem 9 is here. Okay, so I will draw this here. So we have a problem 9. All right, so we got -1, 2, 3, 4, 5. There's an empty circle here. This part of the graph doesn't really matter. So let's draw like that. And then down here at -5, 2. Ooh, what happened? 2, 3, 4, 5. -5, 5. There's a solid dot. And then it goes like this. Okay, so that's the graph that we have. So what were we asked? So the things that they could have asked were limit as x approaches 5 from the left, limit as x approaches 5 from the right, the two-sided limit, x approaches 5, and they could have also asked for f5. Now, what did they ask for? So looking at the problem, they actually asked for the limit from the right. So the one that they wanted was this one. Okay, so this is where the actual answer is for that problem, but we'll go ahead and come up with all 4 of these. So yes, I'll use pink there. So the way we start, we got limit from the left. So limit from the left is, again, this is the left side over here. So you're going to be approaching 5 from the left. So that's this way. So where do you get? Well, you should be able to see that you get to a y value of -1 there. Okay. Now for the limit from the right, which is what we actually are supposed to be doing, that'd be from the right. This is the right side. So you trace the curve this way, like that, and we're going to get to a y value of -5. So that's the answer there, -5. Now, The third thing we've got here is x approaches 5. That's the two-sided limit. Well, the two-sided limit only exists if these have the same answer. So obviously they don't, because -1 and -5 are not the same. So these are not the same. So this has no answer. So we can just say that this is the empty set, no answer. Or, D and E does not exist, something like that. All right. And then for our last one here, let's do green, I guess. F of 5. F of 5 would be if there is a solid dot, which there is. So the solid dot is right here. So this would be F of 5. So that is -5. So again, this is the one that you would be looking for. Okay, just because that's the one they asked for. Now, let me just say, I guess, one more thing about this. Because if you had trouble with these, then you probably had trouble with, continuity. Yeah, with continuity. So let me just say something about continuity. So again, there's these four things, right? We've got limit from the left, limit from the right, and the function value, and the actual limit. So let's do this. Limit x approaches a from the left. Limit x approaches a from the right. Why did I write the word limit? That's weird. Limit x approaches a, f of x. Two-sided limit x approaches a. And then finally, the function value, f of a. Okay, so all of these have answers, right? So if you have all four of these have the same answer. So like if this is L, and this is L, and this is L, and this is L, then the function is continuous at x equals a. So if all of these come up with the same answer L, so if they all have the same answer, then f of x is continuous at x equals a. And that's the definition of continuity. If the function value equals the limit. So formally we say it this way. If the limit as x approaches a of f of x equals f of a, then f of x is continuous at x equals a. So that's the definition of continuity. And the thing about that, though, is in order for this one to exist, this one right here, you have to remember that for this to exist, you must have that the limit as x approaches a from the left equals the limit as x approaches a from the right. Right? So when we were talking about this right here, limit as x approaches a from the left equals the limit as x approaches a from the right, that's what we were talking about up here when we said this number and this number, these two, have to be equal in order for this one to exist. So basically, if these two are equal, then the third one will be equal, right? If this was -1, -1, then this would be -1. So if the first two are equal, then the third one's equal. And if the first three are equal, and the fourth one is also equal, then that's continuity. continuous. So yeah. So coming down here, looking at this, um, if these two are equal, then this one's automatically equal to the first two. And then if all three of these are equal to the fourth one, then the function is continuous at x equals a. Um, yeah. So I think that's what I have to say about that. So that's not a that is not one of the problems you asked about, I don't think, but that's the way it goes. So of course this function is not continuous. Problem 9 is not continuous because obviously these numbers here did not come up all the same. And problem 7, um, this one's not continuous either because these did not all come up the same. So not continuous. Okay. So I think that's it for now. Got to do office hours. So I'll end the video.